Hello everyone, welcome to today's class. Today we have a very nice question before us. We have been asked to differentiate the function y equal to x to the power of ln of x. So how do we differentiate this? Can we use the implicit differentiation? Can we use the product rule? No. But here we're going to do some simple manipulation that will enable us to differentiate this function. So if you're new here, this is my prowess. Subscribe if you've not subscribed. Okay, so let's go into today's challenge. So we take our first step, which is solution to this question. We are going to rewrite this expression we have here in a logarithm form. We all know that there is a strong relationship between logarithm and indices. So this is in index form. What to convert it to log form? Log, okay, y, the base x, this is equal to ln of x. Okay, so what we have here now is the same thing as this. Now look at this. This is to base x. We have to apply the change of base law, which says that if you have, let's assume you have your log, your k base p, we can change this to m. So if we want to change this will give us here log k base m, then all over log p base m. You remember this law? Good. So what to apply this law right here? So applying this law, we're going to have this to be our log y. We are changing to the natural base, which is e. Okay, so all over our log x base e, everything equal to ln of x. Okay, so what do we do next here? It is very easy. All we just have to do is to cross multiply. But before we cross multiply, look at this function we have here. On the right hand side, we can equally write this in log form. Note that your ln of x is same thing as log x base e. You know this. Why? Because the ln we have here is to base e. So these and these are the same. So what we do, we rewrite this part of the equation in this form. Why? Because we're having this expression on this side. So this will give us here our log y base e all over log your x base e equal to log our x base e. Wow, very easy. So what do we do? This is all over invisible 1. So we cross multiply. So if we cross multiply this, will now give us here log our y base e equal to log our x base e times, okay, let me use multiplication sign here, the log x base e. Now if we multiply this together, what will this give us? So we're going to have this to be our log y base e. This is equal to the log our x base e. So what we do next here is just to differentiate this part and also differentiate this. So we're going to differentiate with respect to our x, right? So if we differentiate with respect to x, then what happened? This will give us implicit differentiation, right? So this will now give us 1 all over y, then the y dx, right? Equal to, then if we differentiate this function here, this will give us 1 all over x, then log x base e, right? So this will now give us here 2 times 1 all over x, then log our x base e. Okay, so let's go down again. Then everything here, what would this give us? So this is going to give us 2 all over s, right? Good. And so we also eliminate this y here. So by multiply both sides by y, so we're going to have this to be the y dx on this side is equal to our 2 all over x, then log our x base e times our y. So this will now give us the y the x, right? This is equal to 2y all over x, then log our x base e. Okay, since we are giving the value of y to be this, which is x to the power of ln of x, so we can now do our substitution here, right? So from here, we now say therefore our dy dx, which is what we'll be asked to find, is equal to our 2 all over x, then times our x all to the power of ln of x, then times log x, then base e, log x base e. Okay, so this is the answer to our differentiation. All right, so this marks the end to this differential equation here. All right, so if you learned something from this video tutorial, give the video a thumbs up, or you are not clear with any of the steps, drop a question in the comment section. We are there to reply to all your comments. Remember, this is my prowess. We all here love you. Bye for now.